Alright guys, so this is our first foldable on how to prove triangles are similar. So our book, this is section 8.2 and 8.3. We're going to kind of merge it into one. And therefore you're going to have homework as worksheets as opposed to Big Ideas Math Online. But anyways, it all should go together anyway, so it shouldn't make much of a difference. So we're going to do this foldable now. Okay, now this looks a little different than your foldable. On your foldable, on one side you have the angle similarity theorem, you have the side similarity theorem, and the side similarity theorem. And when you fold these, what you end up getting is these are on the inside flap. Okay, so these will go left to right in your foldable, but just so I can put them on the same page, I kind of ordered them like this. Okay, so we're going to look at the angle similarity theorem first. I'm going to put theorem here because our foldable doesn't have it. This is a theorem. And this theorem basically tells us that if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Now, this AA right here, this is angle. You may know that. You may remember this back when we did congruent triangles, but if you forgot, you may want to do that. Alright, so this theorem basically tells us that all we need to know is that two angles of one triangle are congruent to two angles of another triangle, and that would mean that the triangles are similar. We wouldn't have to do anything beyond that to show that they're similar. Okay, so the first example in your foldable is this one right here. Okay, so notice we have this 90 and this 90-degree angle, so these angles are the same. So I'm just going to kind of color them like that. Okay, what we know is this angle A is 26 degrees and F is 64 degrees. Now 26 and 64 aren't the same, and we have to show that two angles of this triangle are congruent to two angles of this triangle. We already know the one, which is the right angle. But I also know that if I make this X, then 26 plus 90 plus X has to equal 180. Okay, so remember all angles of a triangle add to 180 degrees. So 116 plus X equals 180 minus 116, I get X equals 64 degrees. So this angle here is 64 degrees. Okay, well, notice this 64 degrees and this also has a 64 degrees. So I can say that yes, these triangles are similar by the angle similarity theorem. Okay, now we want to write a similarity statement. Okay, so I'm just going to start over here with this triangle. I can say triangle ABC is similar to triangle. Well, A, remember, order matters on the second one. I can do the order of the first any way I want, but the order matters on the second one. So my angle A is 26 degrees. My angle B is 90 degrees, and my angle C is the 64 degrees. So when I write the order of this triangle here on the right, it has to be in the same order. So the 26 degree angle has to be right here at D. My 90 degree angle is here at E, and my 64 degree angle is at F. So here's my similarity statement. Alright, so the next triangle, or the next, example is this one right here. Okay, so notice, because of these arrows, I know that this and this line are parallel. That's what these arrows right here mean. Okay, and remember, by the corresponding angles theorem, that means this angle here and this angle here are the same, and also that means this angle and this angle are the same. Okay, now because of that, I can say yes, the triangles are similar by the angle similarity theorem. Okay, and now I want to write a similarity statement. So I can say triangle, I don't know, I'll start with the top one, ERS, is similar to triangle. Now remember, they have to match ERS. E, I don't know. Let me just put a double arc. So E is a double arc. My R is this, and my S has this symbol on it. So now when I do the big triangle, I want it in that same order. So my double arc is still E. Okay, my little pitchfork looking arc, that arc is right there at B. And then my double pitchfork looking arc is right down here at A. So this would be my similarity statement. All right, let's look at this last one for angle-angle similarity theorem. Notice I have the 65 degree and the 65 degree are congruent. And don't forget what we learned all the way back in chapter 1. These are congruent by the vertical angle theorem. Okay, and therefore I have 2 angles of one triangle is congruent to 2 angles of the other, so I can say yes, they are similar by the angle-angle similarity theorem. Okay, and then I'm going to go ahead and do a similarity statement. So I can say that triangle CRT is similar to, now my C, I don't have a marking on it. My R, I have the purple on it, and my T, I have the green on. Okay, so go ahead and write and finish this similarity statement to make sure it matches this first one. All right, so the one over on the right that doesn't have any markings is angle A. My purple one is R, and my green one is K. So this would be my similarity statement here. All right, let's move on to the side-side-side similarity theorem. Okay, and this is side, side, side. Okay, and this theorem tells us that if the lengths of the corresponding sides of 2 triangles are proportional, they have the same proportion, then the triangles are similar. So in this theorem, we need to know nothing about the angles. All we have to do is check proportions among the sides. Okay, so let's do this first example. Now, the first example in your foldable is this one right here. So that's the one we're going to do first. So the first thing I'm going to do is I'm going to go and on both of these triangles, I'm going to label or highlight the smallest side yellow. Okay, because I know those have to be corresponding. Okay, now I'm going to label the biggest side purple, and I'm going to label the middle side green. Okay, so this is just to kind of help us visualize or be more obvious as to which sides are corresponding. Okay, now I'm just going to check each of these proportions. So I'm just going to say, well, 6/9. That reduces to 2/3. Okay, and I'm going to say, all right, well, 8/12. That reduces also to 2/3. And here's my last ones. I can say 4/8. That does not reduce to 2/3, and therefore these are not similar triangles. All right, I want you to kind of go ahead and do the same thing on these two and see if they're similar. And if they are similar, go ahead and find the scale factor and write a similarity statement. If it helps you label the small sides the same, the medium sides the same, and the large sides the same, just so you know which sides are corresponding. All right, so if you labeled all the corresponding sides, these are what you should have had as far as similar colors. And when I check the smallest side, it's 3 and it's 4. which just reduces to 3/4. My 6/8, which reduces to 3/4. And then my 12 and my 16 also reduces to 3/4. And therefore, because all of these have the same proportion, I can say, yes, this triangle, or these two triangles are similar by the side-side-side similarity theorem. Okay, now my scale factor I've already figured out. My scale factor is 3/4. If you had a scale factor of 4/3, say you did the other way, I would take that as well. And then my triangle similarity statement, I have triangle JUS is similar to TIN. Remember, if you have this order different, then this order would be different as well. It has to match. All right, so let's look at our last theorem. And once again, I'm going to write theorem right here. The side angle side similarity theorem. So side angle side similarity theorem, also called SAS similarity theorem. Okay, now this theorem tells us that if an angle of one triangle is congruent to an angle of another, and the lengths of their sides, including these angles, are proportional, then the triangles are similar. Now, let's address when I say the included angles. Okay, so if I have a triangle here, if I know this side and this side, the included angle is going to be the angle between these two sides. Okay, so this would be the included angle. Okay, so that's what it means when it says the included angle. All right, so let's look at an example. Now, the first example in your foldable is this one right here. So we're going to do this one first. Okay, we know that this angle and this angle are congruent because of the vertical angle congruence theorem. Okay, now we need to know, is this side and this side, does that have the same proportion as this side and this side? Okay, well, there's only one way to find out. So the blue, I can say 6/8. And if I simplify that, that is 3/4. Okay, then I have my 9/12. And if I simplify that, that is 3/4. So these are the same. So these two sides are proportional to these two sides, and the included angle is the same, and therefore I could say, yes, these triangles are similar by the side angle side similarity theorem. All right, so now that we know that they're similar, we can go ahead and write a similarity statement. So I'm going to say triangle, I don't know, KOT is similar to triangle. Now K is up here, so I want to go to ROB. There's our similarity statement. Our scale factor we've already figured out is 3/4. All right, now I want you to go ahead and try to do this one down here on your own, and then we'll go over it. All right, so from here, the same highlighted sides are the proportional sides or the corresponding sides. And so I checked, and 12/20 does reduce to 3/5. And then 9/15 also reduces to 3/5. Now, with these sides, this is the included angle and this is the included angle, which are congruent. Okay, so I can say, yes, these triangles are similar by the side angle side. And notice when I have this, my angle is between the two sides, just like it is down here. My scale factor is 3/5. It's just the same as the proportion that I found right in here. If you put 5/3, that would also be okay too. And then when I did a similarity statement, I did triangle XYZ is similar to triangle QRS. Now, if you switch the order of this, that is okay. Just make sure you switch the order of this to match it.